Hello, everyone. Welcome to the Carolinas Weather Group. We are excited to have you tonight on the Wednesday, February 24th, 2016 edition. Just a little bit past 8 o'clock. We hope if you are watching right now that either you survived all the active weather today, you have power from all the high winds, and thankfully or hopefully everything's okay where you are. Our thoughts and prayers go out to everyone who's been affected throughout the past 2 days in the southeast from Arkansas and Mississippi, Alabama, Louisiana, up into the Carolinas and Virginia today. I think we did see a tornado that caused 3 deaths in Virginia this afternoon, so I definitely want to be thinking with all those folks who have been affected by the weather today. Our thoughts and prayers are with you, and hopefully you can get up to a speedy recovery and get everything fixed up soon. So with that, it's like we said, been a very active day, and we're going to be kind of talking a little bit about all kinds of severe weather tonight with our guest Levi Cowan from Tropical Tidbits. I know if you're a weather junkie or in the weather enterprise, you've used Tropical Tidbits in your forecasting, and so we're happy to have Levi on with us tonight to kind of talk to us a little bit about everything, tropical weather modeling, and who knows what else we'll talk about tonight. So again, a few housekeeping rules. If you have any questions tonight, please feel free to submit those through Twitter or Facebook, our Google Plus page. We can monitor those. And if you're watching on the redo or the replay edition and you want to ask those questions, we'll let Levi give out Twitter or email however he wants to that you can send those questions to him. So I'm very thankful to have him. He was down in sunny Florida this afternoon. It's a bit breezy down there with temperatures in the 70s, so very, very windy down there. It's windy everywhere. I'm telling you, the wind's howling right now outside of the house. So I told the guys before we came on, if my power goes out, they have to carry on because it's crazy out there. So let's throw it down to Kid a little bit, who's been in the Charlotte area all day today, and let him talk about what's going on weather-wise in the Charlotte metro area.
Well, we had a severe thunderstorm warning for a good bit of like the upper counties around like Hickory and all that, and my sister actually was in Hickory when the tornado warning was issued, and like I hear from Scotty and them that tornado warning for Lincoln, Catawba, and a few others, and 2 minutes later my sister texts me, "Hey, is there a tornado coming here? I'm in Hickory today." I'm like, yeah. So about that, I quickly called her, saw where she was, and she sent me a video. And right at the end, some small like pea-sized hail started hitting her car, and I was like, being in your car is like one of the best places to be in a tornado warning. Anyway, aside from that, later on, a big severe thunderstorm came through with a really heavy rain core, and a good bit of hail was probably in it too. I didn't see any outside, but I was inside. It came over the university area, heavy rain, and then out east, I was watching a lot of storms. There was one that I saw a few with some good correlation coefficient debris ball signatures. So it was an interesting day weather-wise, relatively boring after the front moved through, and I mean cleared out pretty quick. Had a nice sunset and all. But with that, talking about wind, I'm going to throw it on down to Shay Gibson in Charleston right now. Shay?
Yes, sir. Yeah, we didn't get quite the extensive severe weather potential that was called for earlier. Most of that went to our north, up into northern South Carolina near the North Carolina border, and so they got the brunt of that, and I think they're still dealing with some of that through the eastern half of North Carolina right now. But we fared pretty well here along the coastline. In fact, we had our cooler shelf waters really help us out, and that tends to be the case as we go into springtime as well, with cooler shelf waters being around the low to mid 50s. When you get a southerly convergence ahead of all these thunderstorm lines, we tend to stabilize the coastline where we don't see as much activity. So we got spared on that, and so right now we're starting the process of drying out, and west winds are starting to kick up from Gulf high pressure, and that's going to be pretty much the weather pattern for the next day or so as we get back to some sort of normalcy.
Shay, I'm going to put you on the spot because I obviously haven't had a lot of time to pay attention. But did the Myrtle Beach area see any severe weather down up in that area? I
You
know
know,
their school systems closed down today actually for that, and I didn't know if that kind of verified for them or not.
yeah, I don't think so. I think some of the storms passed through early this morning. Don't quote me on that. I need to go back and look at the NWS chats and see what the storm damage reports were. And I usually wait till after the entire event's over before I go and start hunting for what happened where. But I was following some of the radar activity earlier, and I saw some pretty decent squall lines, but nothing on signature from correlation coefficients or anything significant from velocity radar. But the winds definitely did come up into the 30s, and in fact, that was for most cases, even without thunderstorms, we were seeing 35 to 45 mile an hour winds. So, and that even continues now. And I'll do a quick shot up at Outer Banks, kind of show what's going on up there. And can you see the screen?
Yes, sir.
Yeah.
Okay. So even without the thunderstorms being in the area, this convergence is so strong that they're seeing almost exactly what we had here. So I mean, they're seeing 20, 29, and they're gusting up near 40 miles an hour. So that was very typical of us this morning and into all of the afternoon, pretty much. And even at the higher levels, you can see this is surface level, and when we go up to 312 feet at Stumpy Point Tower, you can see the winds are higher. The average is actually up into the 30s in that locale. So you can kind of see some of that layering. The low-level jet really had the clouds racing across the sky today. It was very impressive to see. And there's still some activity going on across the eastern half of North Carolina, like I said. So you can kind of see what's going on there. Some more watches and warnings going up across the board. So we, keep your thoughts on them tonight. They're still going through it.
Yeah, this area. I don't know if you guys can you see my screen now.
Oh. Working on it. There you go.
All right, yeah, this area right here, this is why Ricky's not on. This tornado warning is headed towards the Hampton Roads area where his family lives, so he's helping out with those folks getting the word out. But if you look all the way back here into the North Carolina mountains, it's already transitioned to snow. So that reports some snow falling up in the North Carolina mountains. So just another day here in the North Carolina where you get a little bit of everything. Storm-wise. So also a tornado emergency earlier today in the Fayetteville, North Carolina area as well. So just a little bit of everything out there. So anyways, we'll kind of go back to what our topic is tonight. And we will talk with Levi tonight. I was actually seeing myself on the shot there. It was kind of confusing me. They're good. I think I'm not presenting to everyone now. So
No, you're not.
There we go. I was like, why am I still seeing myself? But anyways, we have Levi on tonight. He is with Tropical Tidbits, and we talk a little bit about everything with us tonight. Levi, welcome to the show.
Thank you very much for having me.
Yeah, no problem. And first question is kind of just tell us what got you here into the meteorology field and your passions and stuff and how you got started and everything.
Well, it's been a long time. I started pretty young in terms of liking the weather. My first love was actually wanting to become an astronaut, which I suppose is pretty typical of a lot of young kids. I came out of that as soon as I figured out that I would get sick doing the somersault training that they have to do at NASA. So after that, I decided I'll try something else. And I have memories of snowstorms in Alaska where I grew up throughout my entire childhood. That's probably what really got me into it initially, was the snowstorms. And I'm sure that's true for many people who live in New England as well. And really no different for me in that respect. But what I guess is interesting is I'm not entirely sure what transitioned me over to hurricanes. My guess is that I was watching the Weather Channel at our local hospital, which was the only place I could watch cable television in my hometown during my younger years. And there were hurricane landfalls in 2002, Claudette, and then Hurricane Isabel 2003. And I think that's what really got me into tropical meteorology, was seeing those storms in the satellite loops on the Weather Channel. And Isabel I remember well because that was when I got my mom to purchase an AccuWeather Professional account for me. And at the time, that was the best place to go get animated GIFs of IR satellite imagery from the tropics. And I just remember Isabel's donut shape being one of the most beautiful things I had seen. And I think that's really one of the events that inspired me to continue studying hurricanes. So that's kind of how everything got started for me.
I must
Great.
unmute myself.
There you go.
I was gonna say,
Was there any one event in particular that you can remember as a being young that really kind of sparked your interest? I mean, you said you talked about hurricanes, but have you been through several hurricanes, or is there like something that you're really like? You talk about hurricanes now, but what's your favorite field?
Well, it didn't. Well, like I said, it wasn't always hurricanes. I grew up in Alaska. I lived in Alaska until a year and a half ago, and so that's the only weather I knew locally. All we had were winter storms. Thunderstorms were a once in a 3-year event, so I looked forward to those. But we don't really have severe convection up in Alaska. So blizzards were really what started me off, and then the hurricane transition, as I said, probably occurred from watching the television, and I really latched on to the beauty of the storms, and I have not experienced a hurricane. I hope to while I'm down here in Tallahassee, Florida. I'm not sure if I'll get that lucky. But regardless, they inspire me a lot, and it's been about 12 years now since I've wanted to start tracking them closely, and that's what I intend to do for the rest of my career if possible.
Well, you certainly have a great skill at it, and you have a lot of fans out there, and we appreciate all the hard work that you do. So leading into that, we definitely want to talk about your website and what you've accomplished over the last few years. So just briefly tell us what you do. I'm going to share the screen on the tropicaltidbits.com, and many of us are very familiar with that site. But tell me how you got into this and what we should be expecting down the road.
Well, the site is kind of a funny story. Its beginnings are really rooted in my blogging history. I used to blog on the Wonderground website, which many of you probably know quite well, and that was really my platform for learning how to forecast in the tropics, was essentially trial and error by posting my personal thoughts on a public blog, and that's what really inspired me to keep going, was the fact that others would read my words, and whether or not they were wrong, which they often were, especially when I was younger and inexperienced, that was what I wanted to do. And it got to the point where I kind of wanted to host my thoughts on my own web server. And this started when I was a freshman in college at the University of Alaska Fairbanks in Alaska. And it's kind of funny because over one summer, my roommate and I, we were both physics students, and both of us like to, we're kind of computer science geeks as well, but we didn't know very much, the two of us, and so we were both toying with the ideas of buying a web host and learning HTML and writing some server code for ourselves and hosting a website. And so I told my roommate one day, hey, I started a website today, and he said, that's cute, how much have you done so far? And I said, well, I've got hello world written on one HTML page. It's like 3 lines of code. It's like, yeah, you probably won't be doing this for very long. We'll probably just end up giving up in a couple weeks. It's kind of funny now. I tease him because that was the beginning of my website, Tropical Tidbits, and I never stopped developing it. I think I spent a solid 2 years from that day onward. Every spare minute of my time was devoted to that project. And the intent for it initially was simply to host my blog. So I embedded WordPress on the website, and that's all it was for quite a while. And I eventually transitioned to most of my video formats. I tend to record now more than write. I find that videos are much easier to convey information to people in a consumable fashion. Not everybody likes to read, multiple paragraphs of text discussion. I think videos are much easier to consume. But anyhow, that was what got it started. And after that, I decided I wanted something more than me to attract users to the website. I wanted to do more with it. And I had these resources, these computational resources, and I wanted to use them. And something I've always been a big fan of is having control over the data that I use. It's kind of a pet peeve of mine. I don't like using other people's stuff. I don't know if that's arrogant or something, but I really like being able to get my hands on the data and the tools that I'm using, and if so, develop my own versions of those tools for my own use. So purely out of a self-interest perspective, I started investigating how to plot model data, and that was really the first time that I started learning plotting software like GRADS that many MET students out there might be familiar with. That's the most primary graphics package that we use to plot things like this. And I decided to start playing around, writing some code, and eventually, step by step, developed the pages that are there now. And mainly for my use, and then I put them online so that anybody who might find them useful could enjoy them too, and it's kind of just gone from there.
Yeah, it's really impressive. I mean, we all have our sources that we go to, and this is one that many meteorologists use because you've done such a great job of putting all of these models together. We have global, ensemble, hurricane, mesoscale, climate models, even in your analysis tools with some of your ocean analysis analogs. This stuff is great. It really helps to sort of get a grand perspective and a grander scope of what's going on, especially in the tropics. So that leads me to the next question. When you are making one of these videos that you do, and they can be sometimes lengthy. I know from personal experience when I do some of mine, I might do several takes, but do you do this all in one fell swoop? Does that come natural to you, or do sometimes you have to do a few takes on it?
Oh, it honestly depends. I would say it's about half and half in that respect. Sometimes when the situation, what I want to say is very clear in my mind, and if the situation isn't terribly complicated and I'm not thinking too hard about what is the proper thing to say to the public to make sure not to lead them astray on what's going on, sometimes it just comes to me and I'll line out the images I want to show and they kind of speak for themselves. But then the other half of the time, sometimes it'll take, sometimes up to 5 or 6 different takes trying to say it the way I would like to convey it and, not slip up. Obviously, it can be hard. Some days are worse than others. Sometimes I need a cup of coffee beforehand, whatever can work. But it's kind of off and on in that respect.
Levi, how many folks do you guys get coming to your website on maybe a weekly basis? I mean, good numbers that you guys pull?
Well, I mean, last year, this is public numbers I posted on Twitter, so I guess I can say them here. We had 21 million hits last year, which blew me away. It was 5 times more than the year before that, and I was very, very pleased. Definitely unexpected on my end. Very blessed that others enjoy the content. I'm very happy to provide it, and yeah, we're definitely up there. So it's rather interesting, the little community of web developers that are out there. I've gotten to know some of them quite well, like Ryan Maui from Weather Bell. We've corresponded, and he's obviously got a wonderful rocking website as well. And the only people around the block, the new kid on the block is actually Pivotal Weather, and I haven't had the chance to meet their developers. I think they're at OU. But there's a nice selection now of modeling websites out there that there's a lot of talent in the meteorology world, a lot of computer science students and web developers that have really showed what applying science and computer literacy together can accomplish. It's really amazing what these people have done.
Yeah, and maybe you could talk a little bit about that a little bit more, I guess I could say. Is a lot of people are saying, the meteorology field is hard to get into if you want to go into TV, but there's so many other outlets that the meteorology field can take you to. So maybe you can talk a little bit about that.
Oh, sure. Yeah. Most people, it's usually the first question asked of me when I say I'm a meteorologist. So are you going to be on TV? Where do you want to broadcast? Yes, it's a big field. There's tons of broadcast meteorologists at my school, but there is so much more out there. The other route is scientific research. If you really like science and scientific literature, if you think you want to investigate questions that you have, curiosities that you want answered, even from a purely self-interest point of view, not just being employed, curiosity drives a lot of meteorologists. I know it drives me, and the ability to answer those questions yourself is very powerful because it allows you to do what you want. So research is one of the potential avenues that you can make a career out of, and usually you're kind of behind the scenes when you do that, but then if you end up getting something nice published, you can get your name out there at conferences and whatnot. So it's not entirely behind a cubicle for your entire life, but you certainly get more exposure on the TV. And the other route, as we just mentioned, is applying some other science to meteorology. Meteorology is not exclusive, and we're seeing a lot of department mergers now, including here at my school at FSU, where we've merged the Earth and ocean sciences all together, and the computational, the computer science department and the math department here are in the same building as well, and it's for good reason. They complement each other quite well. So if you're coming from a math interest or a computer science interest, if all you know how to do is program, or all you know how to do is solve equations, you can apply all of that in the field of meteorology. Even if you don't particularly have a strong passion in this field, there are amazing applications for it. One is web development. The other is data analysis. The amount of linear algebra that we meteorologists have to learn in calculus and differential equations, all of that math gets applied. It's not just learned and forgotten, it's used, and it's used a lot in research and everything else that we do. Products that the National Weather Service uses were developed by a lot of engineers and mathematicians and software designers, and so there's a lot of intertwining of these fields that is possible.
Yeah, just one thing to confirm that. I've got my camera off because the Wi-Fi is slow here on campus, of course. But one thing that a lot of the meteorology majors here at UNC Charlotte do is that we do take so much math that we can already go ahead and get a math minor by just taking 2 extra classes. And there's a lot of different classes that are in the math department. And one of the things I want to look into is graph theory. And I know I'm possibly going to be taking another computer programming class that's taught by the department here, and I'm going to look to see how much of an application in graph theory there can be to computer modeling, because a lot of times there's a large complex system that can be reduced but still contain all of the quality of the system. And like I said, I still have to take the class. That's next semester. But what kind of math classes have you been taking that you're thinking about applying to meteorology?
Well, most of my math came in my undergrad. I haven't done as much in my graduate school yet, but I took a linear algebra class in my senior year in undergrad, and I would say that has been one of the most helpful classes that I've taken. In atmospheric dynamics, there's a lot of application of things like matrix organization of linear equations, and just from getting through MET classes point of view, math classes like linear algebra are extremely helpful, but also in my research. I don't know if this is getting a little too technical, but some people may have heard of decomposing patterns that we see, say the North Atlantic Oscillation, which many people know of. That comes from the first primary mode of variability that explains the North Atlantic, and that is a linear algebra concept where you can add modes of variability together to get reality. And the leading mode of variability in the North Atlantic pressure field is the North Atlantic Oscillation Index. And that is straight out of linear algebra. And learning that in my math class really helped me to understand what that means. And after you know what that means, it helps you understand the NAO better, and then helps you understand what the NAO leads to and how to interpret it. So the math actually ends up helping your understanding of the physics in that case. Math doesn't always help you for the rest of your life, but some aspects like that, it does help quite a lot.
Yeah, I'm currently taking linear algebra right now. It's a little rough, but I'm powering through it. We're just talking about matrices the past 3 weeks.
It's certainly fun.
Well, kind of going on that, that's actually a good segue talking about the NAO. I definitely wanted to ask your thoughts on the upcoming El Nino fade or phasing towards ENSO neutral, and then eventually into possible La Nina by mid to late summertime. So, and we always keep all these oscillations in check. So the NAO, the Arctic Oscillation, the PDO, Pacific Decadence, Madden-Julian oscillations. All these are part of your tropical forecast that you talk about. How do you what are your expectations for this year coming with what's going on with El Nino?
Well, it's a very interesting year. There are still a few things to get ironed out, especially the end of this winter. One of the things I usually look at is what is the Atlantic doing in terms of the sea surface temperature at the end of the winter. And it's a little different this year because the NAO has been positive for most of the winter. We haven't really gotten into a negative NAO regime, and the last time we had a really active year was 2010, and in part that was due to a very warm tropical Atlantic, which in turn was due to a negative NAO during the entire preceding winter. We were coming off an El Nino in that year. As we are this year, we're expecting to go down to neutral or La Nina during the hurricane season. So in that sense, we are like 2010, and 2010 was very active, 19 storms. This year, we don't have quite the same setup in the Atlantic. In fact, the tripole is a little bit different in that we have cooler water in the tropics, warmer water in the mid-latitudes, and cooler water near Greenland. And I could actually probably show that since it was suggested. I can show that map just so you see what I'm talking about. Let me know if it comes up, but I'll keep talking regardless. But this,
Yeah, we've got it.
Okay, perfect. Well, this is the sea surface temperature map globally, and you might be able to see my mouse here. I'll try to circle it. Normally I can draw, but I can't now for some reason. But it's cooler in the tropical Atlantic and warmer in the mid-latitudes, cooler to the north. This is more like a negative Atlantic multi-decadal oscillation pattern, the AMO. And this is a little bit of a unique year for us because we haven't had a negative AMO since 1995 when it went warm in its decadal signal. And in 2010 it was positive. This year it's looking more negative, and we haven't had that in a long time. So even though we're going into a La Nina, it's not quite a guarantee for an active season. Normally, when the AMO is positive, the ENSO essentially dictates whether the Atlantic is active or inactive. In this case, even though we're getting a La Nina probably by the summer or the fall, the Atlantic makes it a little bit tougher. Now, there are a few years we can look back on that are similar to this, and some of the stronger Niños that we might think of are 1972, 1982. The hurricane seasons that followed were 73 and 83, and this was, I believe, the sea surface temperature anomaly in the winter for 73. And so we have the big El Nino in the Central Pacific, and the Atlantic is cold. It's colder than it is this year, but it's a similar pattern in that you get this cold in the east and the south and in the north. And in 83, you have kind of the same thing, cold Atlantic, big El Nino. What happened in the summers of those years during the hurricane season is that the La Nina came. You can see the flip over, so the Pacific looks great, but the Atlantic is cold in the tropics, and you get warm water up the eastern seaboard, which is a problem if storms try to get close to land. But in terms of the number of storms forming, this doesn't look good, and neither does 1983, where again you kind of flip over. The La Nina is still in transition here, but you have this cold water in the tropics. And going back to this year, we're kind of in that mode where we're waiting for the El Nino to flip. The Atlantic, cooler water in general in the tropics. You can see it's not as cold as it was 30 years ago, but it draws questions about how active we can actually get. You want the warm water not up here. Sometimes it's counterintuitive. You don't want all the warm water in the mid-latitudes because that's not where the storms are forming. They're forming down in the tropics, and you want that Hadley circulation to be strong. You want the air rising to the south, sinking to the north, and the way you get that is with warm water in the south and cool water in the north. But when it's reversed like this, it fights that, and so it's harder to get an active main development region here to the east of the Caribbean. And so that's the concern, is that these factors will compete during the summer, making it tough to tell whether we can actually get an above normal year. But with the La Nina coming on, chances are it won't be a dead year. But 1973 and 83 both had very limited activity, so it has happened before where despite the La Nina we get almost no storms. I don't think that'll happen this year, but it's not a slam dunk for an active season either.
Very interesting. So the subtropical jets, would you agree that that's been more or less what's been keeping the NAO in a positive tilt, or do you think that there's something else driving that?
It's often hard to say what governs the Arctic Oscillation or the North Atlantic Oscillation. It used to be thought during 2005 to 2010, we had an almost permanent negative NAO in the winter and in the summer. And it was thought that the constant loss of Arctic sea ice was allowing more heat release from the ocean into the Arctic atmosphere and was promoting ridging, blocking, high pressure, and reversing the NAO. But we've been quickly taught by nature that that can't be the case, because the last 4 years we've had a predominantly positive NAO in the winters, and we've been hard pressed to get very cold winters in the eastern United States for that reason. Since the 2009-2010 winter, it's been hard to get that same kind of blocking pattern. And I would say it's still an open question. I don't have an immediate answer to that.
Okay. So last question on this. I always like to try to figure out what the winds are going to be doing on the East Coast through the summertime with blocking patterns. So you mentioned blocking patterns. So the Bermuda Azores High, in particular, during neutral phasing, I noticed that it was built more towards the east, but we had more undulating fronts along the East Coast. And then last year we saw that back away to the east more, and it was further removed, so we had more of a subtropical ridge in place for many of the events when cold fronts would draw towards the East Coast. So what are your thoughts on the blocking pattern for the East Coast this year?
Well, for the summertime, that's also hard to forecast, but sometimes you can get a hint from both the AMO and the PDO, and right now we're in kind of the opposite pattern that we've been in the last 20 years, and that's that the waters off the west coast of North America are warm, and the consequence this winter has been big ridging up into Canada and Alaska, West Canada, and to try and, kind of forcing troughs down into the east from time to time. That kind of pattern persists into the summer. It's likely that will keep that warm water off of North America, and what that can often mean is you weaken the heat ridge over Texas. That's usually prominent when the PDO is negative. We had that for the last few years. 2010 had a strong heat ridge in Texas. This year we may not have that quite as strong. We might be wetter in the southwest, and that can open the door for storms to come up from the Gulf because more troughs are allowed to dig into the Great Plains during the summer. As far as blocking in the east, that can depend on the interplay between that PDO pattern from the Pacific side and what the AMO is doing on the eastern side. I talk a lot about the SSTs because they really do define a lot of this. It's not the only factor, but it is the primary one. It's the easiest one to predict as well because the SSTs vary slowly. On the AMO side, if you have cold water in the North Atlantic like we do this year, that helps promote a positive NAO because the cold water promotes troughing above it because it's cooling the atmosphere above it. And when that happens, you'd normally expect a ridge upstream from that, and that can form over eastern Canada and help give you the blocking over New England. But that can only happen if the Pacific side isn't interfering with that pattern. And it remains to be seen how the Atlantic is going to set up because I know some of the models want the pattern to flip over during March, and we'll have to see if the Atlantic decides to change a little bit from what its mood has been over the last 3 months. So we have to get through March and April before we'll really know. But normally it is the SST anomalies that tend to set up the ridges and troughs.
Now, one thing I was thinking about earlier when you were talking about how the cold Atlantic temperatures, they just disrupt the Hadley cell. You want that warm tropical water to help rise to the Hadley cell. Usually when it finally falls back down into the subtropics, you get the subtropical high forming. Is that why, since we don't have that Hadley cell as strong, is that why we have typically a lot of those strong low-pressure systems move through the southeastern United States in El Nino years, bringing all that rain?
During the winter time?
Yeah.
That can be part of the reason. I mean, the reason we get coastal developments in general, I learned this in my synoptic class last year, is because the Gulf Stream sits off the east coast, and that changes the static stability of the lower troposphere between the eastern seaboard and the West Atlantic to the east. And so drawing the storms offshore and getting that coastal secondary development is a direct consequence of that change. You get additional instability over the warm water. So yes, when the water is warmer in the West Atlantic in the mid-latitudes, that would tend to favor, more jumping toward the coast, if you will. So I would imagine that does play a role. Exactly how much, I'm not sure.
And Levi, I do a lot of work with emergency managers in the weather field. And my biggest concern, and I've asked several of our guests who've come on throughout the years about tropical meteorology, is our East Coast and even the Gulf Coast, it's been a while since a hurricane's hit down there. And you living in Tallahassee, prime realty for a potential Gulf of Mexico strike. Do you feel people that live on the coastal zones right now are not as prepared as they should be since we've had such a decline in tropical activity over the past several years?
Yeah, Florida especially my part of Florida. I mean, in Tallahassee, we haven't had a hurricane direct hit since Kate in 1985, so it's been 30 years. And I know at least here in Tallahassee, we are nowhere close to prepared for an actual hurricane hit. It's been so long, there's so many new people here, an entirely different generation who doesn't know what it's like to have a hurricane on this part of the coastline. And even the rest of Florida that gets hit more often, it's been 10 years since even a Cat 1 has hit the peninsula. And I do worry, complacency can set in. There are a lot of people who argue that you never forget, the storms like Katrina and Wilma when they came through, and 2004 was, 11 years ago, and they certainly remember, but Florida is, I believe, the second or third fastest growing state in terms of population in the Union. And so there are a lot of new people here in the last 10 years who don't know necessarily what it's like to go through a hurricane. So it is a worry. Down south, the building codes have been pretty good since Hurricane Andrew, and I know since Charlie, they've really upgraded the building codes for new buildings in South Florida again. So they may be better prepared structurally. But certainly here in North Florida, we haven't seen anything really bad in the Panhandle since Ivan in '04 and Dennis in '05, and near Tallahassee, the capital, we haven't had anything in 30 years. And the trees here have grown up so big. My advisor and my lab mates, we all joke about what would happen if a hurricane came through here. We might have a couple months without school, which would be both a blessing and a curse since most of us do research and want to get published. But none of the faculty would be able to get in. We have canopy roads where trees overarch with giant branches that would catch the wind, and just squall lines that come through here have taken power out for 3 days in places when we get squall lines. So to have a hurricane with 6+ hours of that kind of wind, I can't imagine what that would do here. It would be a disaster.
It's something that I worry about because eventually we're going to see an uptick along the Atlantic and Gulf Coast, and I'm afraid that people, like you said, it's been 10 years for Florida, and even though the Outer Banks have been skirted by some hurricanes, there's not really been a landfall in a major area. So it's always a concern to me that people are kind of complacent now, and they don't really think about the potential of a landfalling hurricane hitting their area. And Shay, kind of talking about that, I know you wanted to bring up what could have potentially been a landfalling tropical system late last year.
Yeah, I'll let me share a screen on that because I was looking to see which visual I wanted to put up because boy, I tell you, it was so much going on with that event. So that was one of Levi's last. That was one of your last blogs last year. One of your tropical discussions was of Joaquin as it started to come to fruition on its north to northeasterly track away from the coastline. I think you followed through on that very well. But let's go ahead and share screen. And I did a little blog, weather flow blog on this, and this is just a screenshot that sort of tells it all as far as the flooding for South Carolina. Now here we have the upper low, of course, and Joaquin down here, and we also had high pressure to the north. So we had sort of a Rex block set up, and then there was also a couple little other factors going on around this. Tell us in your words, like what all was going on with this entire event?
Well, this was extremely unique, to say the least. Anyone who's seen the early forecast for this storm knows what a challenge this was. I don't think a single computer model got the track right. Even the European, which ultimately was the best, did not catch the southwest turn toward the Bahamas until it was essentially on top of it already. And I know that's used as an excuse for the ship that went down in the Bahamas, which was very unfortunate, but they did have a couple of days worth of warning from the European model on this. But normally you get up to 5 days lead time on significant track movements like this. Here, the weaknesses of our modeling were certainly exposed. We had a pair of troughs interacting with the storm, and we had this very poorly analyzed mid-level high over Cuba, which may have helped direct it toward the south, but perhaps more likely is the model struggling with latent heat release from the storm being deposited on perhaps its western side and enhancing the ridging there, forcing it toward the south. That interaction was not modeled very well. it was very interesting also to watch it intensify quickly after beginning to move toward the northeast. Moving away from the United States, that was probably in part due to its interaction with that little upper low that you can see in the image there to the north-northeast of the storm. There was the main trough over Georgia there that was steering it to the north, but there's that upper low to its north-northeast as well, and that was enhancing the upper outflow from the storm quite significantly at the time. And there was even some shear over the storm, but sometimes these little troughs, when they interact with the storm, especially when they're small, yeah, that one right there, can really take mass out of the storm in the upper levels and cause very quick intensification. And it was almost a Cat 5. It may have been. I think the recon sampling at the time was suboptimal, so it may have reached Cat 5 for a few hours when the plane wasn't looking.
What about Ida back here? Wasn't Ida part of this as well?
Yes, I believe so. Yeah, that furthest to the right circle you've drawn, I think, may have been the remnants of Ida. I forget exactly what that evolution looked like, but I believe the storm dissipated as it was coming toward the east. I know there were a few very fun runs from the Canadian model, which, for anyone who follows the tropics, know is endlessly entertaining to watch, where it had a Fujiwara interaction between the two storms.
I call that the Fujiwara, the triple Fujiwara effect, I think is what I was trying to name it. I don't know.
It was pretty ridiculous, pinwheeling 2 or 3 vortices into the eastern seaboard. Pretty nuts forecast, but always fun to watch.
Cool. So yeah, I mean, we were just upstream right here. We got absolutely hammered. We had, but I think one spot had about 22 inches of rain, and one location from the Coco Ross network reported 24.6, I believe, or maybe in 26.4. I have to go back, but I think that the main average was 20 to 22 inches, and it was just incredible to witness that and see how that all played out. Because I don't think anybody was expecting it, and the WPC, hats off to them. They did a great job at nailing that event 2 to 3 days out. So we were, at least we knew ahead of time what was coming.
It's very fortunate that Joaquin did not actually follow that trough in, or that would have been at least twice as bad. It's very fortunate that you guys lucked out there. Many people still think the hurricane contributed directly to that rainfall, and it really did not very much. In fact, if you look at the moisture fields at the time, there was only a very slight connection. Most of that lift was being generated by the trough itself and had nothing to do with the hurricane at all. So all of that rain was unrelated to Joaquin. Many still think it is, but if that hurricane had indeed come into the coast like it was originally forecast, it would have been a lot worse.
Yeah, one of those things, like I was in my tropical meteorology class during the event, and we were talking about, like, just the week before Joaquin happened, we were talking about what that type of setup would be called a preliminary rain event, PRE, usually that's what it's called. And usually you'll get a couple days of really heavy rain, and then you'll get the hurricane, and that's when you get like the higher levels of just devastation from the immense flooding, the ground being so saturated from all of the water, and then the high winds of the hurricane just wipes out everything.
Were you guys around for Floyd in '99?
Yes, it was close call. That was I was gonna ask you that question. Which was your most impressive hurricane that you've ever covered? We can talk about that whenever you're ready. Yeah, Floyd was, had everybody evacuating. So that was the last time we had to evacuate. That was a long time ago. I'd be interested to see what it's like now. So, Levi, I did want to ask you your most memorable tropical system that you've done blogs on or you've done research on, anything. Tell us about it.
Well, I probably would have said my most memorable experience was Wilma, up until last year when Patricia came along, and those two storms are rather...
Uh-oh, I think he froze.
You cut off?
Uh-oh.
They may have had a squall line go through there and knock the trees down.
I don't see anything much down there, I think. Let's see here.
Right off where I am.
He may come in and not know that he's out, so... But
Right. Yeah, Patricia. For those watching, Patricia was, I believe, was named the most powerful hurricane or cyclone in the Pacific to make landfall. It was one of the strongest in the the northern hemisphere, and the winds were up to what I think peaked out at about 215 miles an hour, or I think that was about right. I don't have all the details there, but
I think I saw 200 knots at one point.
200
But
knots.
it was the strongest hurricane, which is named after the National Hurricane Center in Florida. It was not the strongest cyclone ever. That still is held by Typhoon Tip that was in the Pacific in late 90s, early 80s.
Right. Too far east. And I think Levi is back with us. Can you hear us?
Yes, can you hear me?
Yes, sir.
Got you.
I'm so sorry. I think my Wi-Fi went out for some reason.
It happens. So I think you were just about to talk about Hurricane Wilma coming through, as well as Patricia.
That's right, yeah. So both extraordinary experiences. I know it's rather cliche that these are the two strongest storms, respectively, that formed in those two basins, the East Pacific and the West Atlantic. Wilma, especially 11 years ago, I was still pretty young at the time, and waking up Alaskan time in the morning to see the recon flight that showed an 80 millibar fall from the previous day. Pretty hard to believe. I was probably an emotional wreck at the time. I don't know how I would have dealt with that today, but I got a chance to get close to that feeling with Patricia. I was up late texting all of my friends at FSU, and they were all asleep. I couldn't believe they were asleep, but I was watching the data come in for Patricia, and there's nothing like watching something rapidly intensify. I think that has got to be the biggest high a meteorologist can get, is watching a hurricane undergo rapid deepening. And to see records broken, it's something that you know you're not going to see very many times in your life, if ever again. And those records set by those two storms may never be broken. There are some estimates from dropsondes in Patricia. I saw a presentation the other day from somebody who has analyzed the data that was showing winds possibly in excess of 120 meters per second, which is 250 miles per hour in the storm. We're talking gusts here, not sustained, but some of the most extreme winds in the world, and watching those storms evolve was certainly something very special. Certainly we were lucky that Patricia didn't hit either of the two population centers that it was close to at landfall. Wilma obviously went on to cause more damage, but in the moment, as a meteorologist, before landfall is something that is entering your mind, just the meteorology of it alone, there's nothing like it.
We were just talking about Patricia. I'm trying to jog my memory here. Strongest hurricane in the Western Hemisphere?
Mm-hmm.
Is that right? Okay, I think I said northern earlier. My apologies to the audience. It's the Western Hemisphere, not the Northern Hemisphere. So, and top winds that were recorded?
I believe it was 185 knots now after reanalysis. That's 215 miles per hour sustained. The only other, it ties Typhoon Nancy from the 70s for the official record for the Northern Hemisphere, in fact the globe. But that record is questionable. Typhoon Nancy was based on old recon data that was likely biased high for those couple of decades, the 60s and 70s, when we were flying typhoons. We don't do that anymore. But when we flew typhoons, most of our wind data was biased pretty high. And it's likely that Patricia was actually the strongest ever observed. Even those typhoons probably didn't get close. And when you think about it, Patricia, I believe the minimum pressure was 885, or I'm sorry, I can't recall the exact number right now. It didn't beat Wilma at 882, but it was 885 or something like that. And in the East Pac, the base state sea level pressure is much higher than in the West Pac. So that kind of pressure gradient is even more impressive than possibly even Typhoon Tip, which got down to 870. And so although Tip held the record for pressure, in the West Pac, that's a little bit of a different story because you're about 5 to 10 millibars lower than the Atlantic and the Pacific. So it may be that Patricia is actually the strongest we've ever seen.
Right. I think Wikipedia, just for the general audience, Wikipedia does say 872 millibars is the lowest pressure.
872, okay.
872.
I apologize. Yeah, they reanalyzed it about
Right.
4 millibars lower than the original estimates. And I think they based that actually not off of exact recon data, but based off of an extrapolation from satellite appearance that continued to improve even after the flight left. So that was certainly very impressive. So only 2 millibars off from the world record from tip, but in the East Pac that means a lot more. So extremely impressive.
It does get tricky. I mean, you get information that keeps changing from hour to hour, and what you thought was one thing, and someone else's, the JMA, they're saying something else, and one agency might be using the Dvorak technique. So when you're using satellite information only and not physical data from dropsondes or recon, how do you go about determining the strength of a storm if you're just given a storm out in the Atlantic and you need to determine how strong it was? What kind of techniques would you use?
Sure. Well, our most valuable is indeed the Dvorak technique because it's usually the highest temporal information that we have every half hour, and when GOES-R goes up, we'll have every 5-minute data, and those algorithms will be able to improve. But when it's weak, especially, the Dvorak technique can be rather poor, and also when the eye is cloud-filled, that can play a big role. And often microwave images, those polar orbiting satellites that come over and give what are essentially radar pictures. That's not quite correct, but it's like a radar picture of the storm. And that gives us an idea of the internal structure, and that's often the most valuable piece of information, I find, especially for weaker systems where you want to locate the center. Sometimes satellite imagery, conventional imagery, can fool your eyes. There's a lot of optical illusions that occur. It can fool you into thinking there's a spin or a low center somewhere that it's not, or maybe something is only a mid-level center, but not at the low levels. And so that can play a big role in determining how strong the storm likely is. So knowing exactly where the center is very helpful, and there's actually a brand new computer algorithm that I believe they're launching on the SIMS website for those who use it. They publish the automatic Dvorak technique, and they also have this new algorithm called Archer, which recently got published from the Joint Hurricane Testbed. And it's a new algorithm that takes microwave data and locates objectively where the center of the TC is likely to be. And I'm not sure if there's any active cyclones still up on the SIMS page now, but if there are, you can click on the Archer link and it'll show you the examples of what they do. And that's going to be very useful to us in the Atlantic this year and for many years to come, because humans can make mistakes when analyzing that kind of data, and to have the objective tools available will be very helpful.
Do you ever use the advanced scatterometers?
Oh yes, I certainly can't leave those off. I'm sorry, I got caught up in microwave techniques, but yes, scatterometry certainly invaluable, and more than ever we need a new QuickScat satellite now. I know we have RapidScat on the ISS for a couple of years. I think we're still trying to work with some international missions to get a better satellite up there, better than ASCAT, which currently has very thin bands, and often misses the storms. Quite frustrating when it does miss. But very invaluable to have the lower level winds, again, for locating the center, and of course for directly assessing the strength. For weaker storms, it's very accurate. For hurricane strength storms, the wind speeds are less useful, but for defining when genesis occurs, it's right up there at the top of the most useful tools.
Yeah, I just found the Archer tool on the SIMS website, and they still have Tropical Storm Winston up there, as well as a new one, Tropical Storm 14 is what they're calling it. But just wanted to confirm that was up there.
Yeah, I think Levi's tropical, your current storm information is great, because before, I think you were zeroing in on active storms and mainly in the Atlantic Basin, the Pacific, and now you're covering the globe. So it's great because you're talking about Pacific storms and Atlantic storms in your discussion. So for some of those Western Pacific and even into the Indian Ocean areas, I would love to hear some blogs down the road on that if that's something you'd ever be interested in, or even in the Southern Hemisphere. There's a lot going on out there. But I know that we're kind of nearing up on the 9 o'clock hour, and I have one more question, and I'll throw it to Kit and Scotty, and that is, with the new supercomputing coming out from NOAA, what are your thoughts on what that's going to add to us, and are the Europeans answering back by upgrading their systems as well at the same time?
Well, the Europeans, make no mistake, are still at least 5 years ahead of us in model development, and they actually use far fewer computing resources than we do in total, because NCEF's primary mission right now is focused on mesoscale modeling and climate modeling. less so on medium-range deterministic prediction. So although we are throwing a lot more resources at the GFS now, it has been lagging for some time because the Europeans have a single focus, and that is their IFS model, the ECMWF, as it's better known. And they'll probably be at the top for a while. I know we're just now starting to introduce 4D variational assimilation of data into the GFS. There's an experimental version of the model which doesn't change any of the physics, just the data assimilation, which helps define the initial conditions, the analysis in the model, and that is improving the forecast a little bit in the experiments so far. And I think they are upgrading that just prior to the hurricane season beginning. So that will be interesting to see how it does during the hurricane season. It's a little frustrating because the model is changing a lot in the last couple of years, and so you don't know what to expect as a forecaster. You get used to the same version of the model for a couple of years, and you start to see the biases in how it forecasts hurricanes. When it changes on you like this, you're starting back at square one, and you're not sure what to expect. But the new computing resources will, of course, help. The focus right now has been primarily on increasing resolution, and while that does solve some problems and increase skill in some areas, especially in forecasting TCs because they are small scale and are still poorly resolved by global models, there are also some deficiencies. And it comes out sometimes in the GFS where convective feedbacks at smaller scales lead to different types of errors, especially in the tropics, and we see it in sometimes these convective events, these severe events in storm tracks along the eastern seaboard where sometimes the GFS is too close or too far from the coast. It can affect things in the winter as well, and of course there was the famed bust of some of the models last year with that blizzard in New England where some of those processes were coming into play as well. So although throwing more computer resources at the problem does help to some extent, there's a lot of physics that need to be researched and how to fine-tune the parameterizations to get the models to increase their skill.
Interesting. Kit, do you have anything else?
No, I mean I've started using your website after or during my words. I started using that website during my tropical meteorology class last semester, and I love it. It's one of the ones that I've been going to recently, just forecasting everything. It's got all the models there, and it's just a really great tool that you've put together, and I really appreciate all the work that you've done in making it what it is.
Well, thank you very much. I appreciate that a lot.
Well, since it is 9 o'clock and Scotty's power cut out on him, so he tried to come in on his phone, I think, but that went out too, it seems. But we usually have one question that we always ask all of our guests that we have come on. And that's Joey isn't here tonight, but it's sort of his question. And Joey's question is, what is the one piece of advice that you would give a student who's looking to come into meteorology that you would give them that would best help them further their aspirations of their career?
That's a very good question. I would probably say if you're coming into meteorology and you know that's what you want to do, find a way to actively pursue that passion. I would say that extracurricular activities are the reason I am where I am today, and I know a lot of students, I've seen a lot of students, I've taught some classes here, and some students, they come to class, they learn, they like it, and then they go home and they don't really do much in meteorology outside of class. And I think it's very important, especially while you still have time. In undergrad, you still have a little bit of time. In grad school, you lose a lot of that time. But when you still have it, use that time to pursue your passion. Find what talent you have, whether it's programming or forecasting. Find something that can help you further your knowledge. And by exercising your passion in that way, you'll end up learning so much more than just going to class every day. And it's really worth spending the time to learn as much as you can while you have the chance.
And obviously apply that information into things like what you're doing with, I mean, not so much go start a website, but any of these extracurricular activities like that, things that you do. So we appreciate everything.
All right, well, any other questions there on your end?
I have nothing further.
Levi, any other comments that you'd like to say?
Just that I'm very grateful that you guys gave me this opportunity. I think you guys are doing a great job, and I really appreciate you guys having me on.
Yeah, certainly. Thanks for coming.
You can throw
So
some credentials out there. Don't forget that.
yeah, if you'd like, if you have a Twitter that we can follow you on, and pop that out there. If anyone has a question that they can send to you, how can they get in contact with you for the rest of it?
Sure.
All right, so Twitter at Tropical Tidbits, is that it?
That's correct.
All righty. So everyone be sure to give Levi a follow on that. I'm sure he has lots of great content coming out all the time. Looking ahead to the rest of, well, next week, I believe we're on break because the next show we have is Almanac Accuracy coming up on March the 9th. We'll be talking about the Farmer's Almanac and how well that does or how well it doesn't do. Once again, we will be posting this. This was a live event, but we will have it on YouTube for you to watch. And if you have any questions, you can comment here or tweet at Levi at Tropical Tidbits on Twitter. For the Carolina Weather Group, I'm Kit Cloninger. Everyone have a good evening.